Hello and welcome back. In this slice of physics, we will discuss unit conversions. This is something you will be doing fairly frequently in this course. We will demonstrate the standard method of unit conversion, and we will do this with a couple of examples. For fun, we will figure out your age in days, and we will figure out the speed of typical cars on freeways in SI units, or standard international units. Let's begin with the first example, and let's say that a student in this class is 21 years old, and we want to know how many days old is this person. So the first thing we need to convert from years to days is a conversion factor, which in this case is 1 year equals 365 days. And for the sake of this illustration, we're going to ignore leap years. In order to see how we will use this conversion factor, let's take an example of how we work with fractions. So if I had a fraction that was 4/5 and I had to multiply it by another fraction that was 7/4, we could simply cancel the 4 at the top with the 4 at the bottom and get our answer of 7/5. This kind of cancellation works with units as well. So in order to convert this age to days, we would simply write it as 21 years, which is what was given to us, and then we would multiply it by a conversion factor, which would be written as 365 days over 1 year. Now, just like the 4's canceled, here the year in the bottom is going to cancel with the year on top, leaving us with a unit of days, which is what we wanted. And the rest can be done by our calculator, which when you multiply 21 by 365, you will get 7,665 days. So that is your age in days, and here's your answer. Now, a couple of points about this. How could we get away with multiplying it by this fraction? First, you know that multiplying any number by 1 does not change its value. So as long as this factor we multiplied with is equal to 1, we did not change the value of the age. We just converted it from one unit to another. And you also know that any fraction where the numerator equals the denominator is simply 1. And given our conversion factor, we know in this case 365 days equals 1 year. So this fraction is simply 1, which is why this whole technique works. The second comment I want to make is we were pretty clever in how we use this conversion factor. So for example, we could have multiplied the 21 years by a conversion factor that said 1 year over 365 days. Nothing wrong with that, and it also does not change its value because we're multiplying by 1. Numerator equals denominator in this case as well. But this is not very helpful. The year in the top and the year in the top will not cancel, so this way of writing the conversion factor will not work for us. So this is not very useful, and the useful way of writing the conversion factor is like we did here, such that the units we don't want cancel and the units we do want remain. Okay, let's now take our second example, which is a little bit more advanced in terms of unit conversion. So the speed of cars on typical freeways, let's say, is 65 miles per hour, which is written as mph. And we want to convert this to a speed in standard international units, which is meters for distance and seconds for time. So we want to know the speed of cars in meters per second. First, let's understand what this mph or miles per hour means. If I'm traveling at a speed of 65 miles per hour, for every hour that passes, I travel a distance of 65 miles. Mathematically, the per translates to a division function. So 65 miles per hour simply is the same as 65 miles per, for division, hour at the bottom. So that's our speed. And we want to go from this to meters per second. The relevant conversion factors in this case are 1 mile equals 1,609 meters. 1 hour equals 60 minutes. And since we want to go to seconds, we got to have a conversion factor all the way to seconds. So 1 minute equals 60 seconds. So there are our conversion factors, and now the question is, how do we use them to convert from miles per hour to meters per second? So let's start as usual with writing our original speed as 65 miles per hour. And the first thing you see here is that we have miles in the top, and we don't want that. We want meters instead. So we need a conversion factor between miles and meters, and it's best to write miles at the bottom so that the miles will cancel with the miles on the top. So we write 1 mile here and 1,609 meters here, which will get us from miles to meters. And then because hours is at the bottom, we got to put our hour at the top so that it cancels it. And to keep the fraction 1, I got to put 60 minutes. And this will go from hours to minute, but since we want to go all the way to seconds, we got to keep going, put 1 minute at the top to cancel the minute at the bottom, and put 60 seconds here. So now we can begin canceling things. So we got mile canceling miles. We got hour at the bottom canceling the hour at the top. We got the minute at the bottom canceling the minute at the top. And what we're left with is simply meters here and seconds here, which will give us the speed in our desired units of meters per second. The rest, once again, is done by a calculator. So when you take 65, multiply it by 1,609, divide it by 60, and divide it by 60 again, you get 29 meters per second, where I have rounded the final answer to just 2 significant digits because our inputs of the lowest precision were 2 significant digits as well. So there we have it. A speed of 65 miles per hour is the same as a speed of 29 meters per second. So in this slice of physics, we have reviewed the standard method of unit conversion and used it with a couple of common examples to refresh your memory and get you prepared for what's coming up on this course.